Okay, so just a quick video on, just a quick recap on how to use the z-score formula, calculate a z-score. So we have our example that we used in class. We have Jenny, who scored an 86 on her test. She wanted to know how she compared to the rest of her class. So what she did was, instead of asking each student what they made and doing it one by one, all she needed to do is find the mean and the standard deviation of the class. And she used the z-score formula to calculate that. So she scored an 86, so that is her observation, minus the mean of an 80, divided by the standard deviation of 6.07 in this case, and that gave her the score of 0.99. So that tells her that she was almost one standard deviation greater than the mean. That's all well and good, but that doesn't really tell us a whole lot of information. But if we now assume the results are approximately normal, then we can use a bit of calculations to figure out just, more specifically how much better she did than everybody else, right? Jenny's a bit of a vain person, so she wants to know exactly how much better, who she's better than, how many people she's better than versus how many she's not. So what we can do, we can take our z-score now. That was fairly easy to calculate. And then use our table, our standard normal table, as you see here, to find exactly what proportion of her class she scored better than, and we can easily turn that into a percentage. So here we have, let's see, 0.99. So we find 0.9, which is this row right here, and then the second decimal point will give us that right there. So we find where these two meet, and we see that she scored better than 0.8389 of her class, or in other words, almost 84% of her class. So she would be in the 84th percentile of this class, right? And that's great, which means she also, you can do the flip side of that. You calculate, 16% of the class did better than her. So if this line right here represented Jenny's score, this area here would be the 0.8389, and this over here would be 1 minus that. I'm not going to write all that. That's too small of a space. Another thing we're able to do is say, all right, well, maybe I want to, or maybe I know exactly how much or what percentile I'm in, right? Given that it's normal, I want to calculate what my score is. My teacher didn't give me my score. She just told me, I'm not going to tell you what your score is, but let's just say you did better than 70% of the class. I'm like, all right, that's not very useful, but I'm good at stats. I can figure that out. So we look at our table and we say, okay, well, if our data is normal, then 70% would be halfway between these two numbers, right? We have 69.85%, 70.19%. So we'll approximate. We'll say it's at 0.525. So my z-score, hypothetically in this case, would be 0.525. And that doesn't really tell us a whole bunch, but what we can do is say, well, I know the formula for the z-score is just my observation minus my mean, which, assuming it's the same test, was 80, divided by my standard deviation, 6.07. I can do a quick bit of algebra to figure out what x is. So let's do that real quick. Should I? Yeah, I'll put this over here so I can get my calculator. There we go. So 0.525, we'll multiply by that denominator. And then we'll add 80 to it. Sorry, it's hard to read these little buttons. And that tells me that I made an 83.18 on my test. So that's good. I didn't do as good as Jenny, but, I got a B. So maybe you're saying, hey, we live in the 21st century. These calculators are very powerful. Is there anything we can use on these that would maybe make our lives easier? And yes, frankly, there is. So what we can do, let's say we don't want to use this. Granted, you will end up using this pretty frequently because this calculator can't do everything, but it can do a lot. So we can say, all right, well, let's go to our trusty old menu, the name of the class that you're taking, that thing that Mr. Poulter mentioned, distributions. And what we're going to do here is we're going to use a normal CDF. What this does is, here, let me use the picture. Basically, if this is our distribution function here, the normal CDF, we can set our boundaries. You know, our lower bound can be negative infinity or 0, or whatever we want it to be. And our upper boundary can be whatever our z-score is in this case. Or if we want to flip it and we want to calculate this, we can make our lower boundary the z-score. We can make our upper boundary positive infinity. But we can calculate basically the p-value, the proportion, or the probability underneath the curve. So in our example from before, you know, maybe Jenny's friend was like, great, you made a 86, I made a 90. So I want to know how much better, how many people in the class I'm better than. So we'll set our upper bound to 90. Our mean for this test in this hypothetical class was 80. This class is filled with very petty hypothetical people, and our standard deviation was 6.07. And we see that we got a p-value of 0.95, meaning that Jenny's friend did better than 95% of the class. Maybe we have a very self-conscious person who is not so much interested in, or you know, maybe I'm not sure what the word is. They're more of a pessimist, right? Maybe they want to say, all right, I don't want to know how many people I did better than, I want to know how many people I did worse than. They can do the same thing. Maybe they got like an 82. You know, it's better than the average. What we can do is say, all right, well, maybe my lower bound will be 82. My upper bound will be, well, you can't write infinity in the calculator, can you? So just write a bunch of 9s. Actually, the fastest way and the most precise this thing can get, if you do 9 to the 999th power. If you put an extra 9 there, it'll, you know, spaz out. But what was our mean? 80. And again, standard deviation, in this case, 6.07. We see that this person did worse than 37% of the class. So this pessimist can see that they're not, that, you know, the sky's not falling after all. The world's not ending. Maybe you know, again, is the case of, you know, me, the teacher wouldn't tell me what my grade was, but they told me that I did better than 70% of the class, which is, you know, is weird. Again, petty students, petty teacher, what are you going to do? I can say, all right, well, again, I'll use my distributions. I'll use my normal distribution. But since I have the p-value and I'm trying to get the score, I use what we call the inverse normal. Again, I know I did better than 70% of the people. I know my mean was 80, and I know my standard deviation was 6.07. Now, it would be useful enough if this would give us a z-score, but we can get that from the table. This is actually just going to give us this straight score. So this tells me I did an 83. Again, not as good as Jenny, but better than this pessimist over here, who made an 82. So again, very powerful, very useful.